In this video, we're going to be seeing if we can figure out what the equation for a graph is if we don't know those parameters to start with. Now, I've got this panel open at the moment because I want to show you that I can change this from sine to cosine and therefore change the graph. I can change the value of A, I can change the value of B, I can change the value of D, and I can change the value of C. I won't bother at the moment. But I can change all of those values, so that's exactly what I'm going to do. I'm going to set this to be either a sine or a cosine. I'll set the values for A, B, C, and D, and then I'll close this box I'll close this folder before I come back. So when I come back, you'll see a different graph here, and you won't be able to see what it's made of. All right, so I've changed a couple of things. Primarily, I've added my formula. I don't have a sine or a cosine yet because I haven't decided whether it's going to be a cosine or a sine or a cosine graph. We'll come to that in a minute. And I don't know what my A, B, C, and D values are. That's what I'm trying to figure out by doing this exercise. So let's start in the same way as we did before by finding the midline. Once I know the midline, I can find two things very easily. One is that I can find the amplitude. And that appears to be 2. These units are 1, 2, 3. I'm only getting every other integer here. So my amplitude appears to go from 1 to 3, so that's 2. So I can change A, chose the wrong tool there. I can change A to 2. And I can also see from the midline how far up or down the graph has been shifted. The midline is the line y equals 1 instead of the line y equals 0. So clearly this thing has been shifted up 1 unit. Well, that part was easy. Now the harder part is figuring out what B and C are. And in order to figure out what either B or C is, we have to figure out, first of all, we have to decide whether we're going to treat this as a sine graph or as a cosine graph. So let me erase that annotation. And then it appears to me somewhat obvious that if I simply started here, I could call that a cosine. So why don't we do that? Let's call this a cosine graph. And with that, we can figure out what B and C are as well. Now, B is pretty easy in this case because I can simply count cycles. There's 2, 3, 4. I have to go to 2 pi because that's the normal amount of time it takes to do a cycle of cosine. In this case, it's taking me 6. So that's my B value. Now, that's not always quite that straightforward, but in this case, it wasn't too hard. And the C value is actually pretty easy in this case too, because looking at this graph, you can see that I have shifted to the right or to the left 0. I'm starting right at x equals 0 for my first cycle of cosine. When I ask you to do these, I'll give you A, B, C, and D values that are integers. A, B, and D values that are integers. It's not that they always would be, but for the purpose of doing this exercise, I want you to be able to figure out with some confidence what those values are. I don't want you to have to try to second guess whether this starts at 0 or 0.01, for example. So if you're that close to 0, you can assume it's 0. So that means that my C value is 0 as well. And I don't have to write it as x minus 0. I can just write it as 6x. So let's go ahead and write that out a little bit more tidy. I get y equals 2 times the cosine of 6x all plus 1, which we often see written as 1 plus 2 times the cosine of 6x. In other words, they'll put this 1 out in front instead of at the end, just to clarify things. Okay, I think it's time for the big reveal. Now, I don't have, let me highlight what I like as an answer here. I call this the best format for the answer, but if you write it in the way it's written in the line above, that would be okay too. Take a moment and write down those values, or write down that equation, because I'm going to reveal the parameters in the hidden folder here in a second, and we're going to check and see whether our answer is correct. In order to do that, I have to turn off the drawing tool, and when I do that, all of my annotations will disappear. So take a moment and write down 1 plus 2 cosine of 6x. Y equals 1 plus 2 cosine of 6x. And then I will reveal, I'm going to exit the drawing tool. And I'm going to reveal the parameters. And let's check our answers. Well, D was plus 1, so we got that part right. And B was 6. We found 6 cycles of cosine between 0 and 2 pi. So that part was right. It looks like A was close. We had a positive 2 here. And we had a 0 for C. So let me show you how what we just did was still the right answer, even though it's different from what the graph was actually built using. Let's find the function g of x equals negative 2 times the, by the way, we got cosine right as well. G of x equals negative 2 times the cosine of 6 times x plus pi over 6, all plus 1, right? That's the same graph as we found. And in order to do that, I'm going to show you where I would start. First of all, notice that this is negative pi over 3. So negative pi over 6 would be here. That's half of pi over 3. I'm in trouble with my pen. I'm going to be starting there because I've been shifted to the left pi over 6 units. This is still a plus. I had a minus in my formula. So I'm going to be starting there and then moving to the right. So I'll go here until I get to here. If I have to start at this point right here, then that makes that a cosine graph, right? I'm starting at a max or a min, not at the midline. Now, I started at a minimum, though. I started down here instead of starting up here where I would expect to start a cosine graph. So that makes the a value have to be negative 2. So that works. And then I've started pi over 6 to the left, so now that's correct as well. So these parameters give me the same graph as the equation that we found a few minutes ago. There are multiple, in fact, technically, there are an infinite number of correct answers. I could start, if I wanted to, here. And then I would have a negative sign graph. The amplitude and the period won't change, so the numerical part of A will be the same regardless. B will be the same, and D will be the same because this graph has been shifted up no matter how you look at it. It's been shifted up 1 unit. It's also got an amplitude of 2, and it's got 6 cycles between 0 and 2 pi. So all of these values will not change. I'm going to make sure that I get just the negative, just the 2 highlighted here, because it's just the 2 that I can count on, regardless of whether this is a sine or a cosine, and regardless of where I start. The only things that will really change are, I'll grab a different color here, are the value of C and whether A is positive or negative. Just to be thorough, let's find the equation of the graph by looking at it from this perspective. It's going to be y equals, this is a sine curve, right? It starts at the midline. I'm going to have a sine there. I said the numerical value doesn't change of the amplitude, but now it's a sine value. It's a sine graph that starts by going down instead of by going up. So it's going to have to be negative 2. I also said that the D value doesn't change. It's been shifted up from the midline, from y equals 0. It also doesn't matter whether it's a sine or a cosine. There's still 6 cycles between 0 and 2 pi. And this time, so the only other thing that's changing here is how far over I have to go before I start. Here's pi right here, and this is 4 pi over 3. Halfway between those two values, that minimum is at 7 pi over 6. And I found that just by taking 4 pi over 3 and adding pi plus 4 pi over 3, and dividing it by 2. I found the average of those two values. So that gives me 7 pi over 6. And halfway between pi and 7 pi over 6 is 7 pi over 12. So I'm starting at 7 pi over 12, and x minus 7 pi over 12. And this equation gives me the same graph as we had earlier and as we are given the parameters for now that we can see them. And my point in doing this one was just to show you that there really are an infinite number of ways that you can find the equation of a graph, a trigonometric graph. I would encourage you always to find the easiest one. So in this case, that would have meant starting here and using a cosine. And that's what we did. That's how we did our this problem initially. And then we found out that's not what was graphed, but it's the same graph. It's a different equation for the same graph. I won't give you functions that you have to know multiples of pi over 12 for, although that's not hard to find. Just as a, b, and d will always be integers, c will always be a multiple of pi over 12, but you should be able to expect to be able to find a function that uses a c value that's a multiple of pi over 2, pi over 3, pi over 4, or pi over 6, or pi. So you don't necessarily need to know all your values of all your radians down to multiples of pi over 12. All right, this one was pretty easy, but I hope you found it helpful. In the next video, I'm going to do either a secant or a cosecant graph. That sounds hard, but actually, if you can do a sine or a cosine, you can do a secant or a cosecant, and I'll show you exactly what I mean.